Today we will discuss examining data analysis. This is the part of multivariate analysis. Before we talk about this chapter, first we will discuss missing data assumption and what are the missing completely at random, missing at random and missing not at random data. First we will discuss about the missing completely at random data. For example, in a school there is a teacher who has 20 tests. He is returning to his classroom after taking the test. His class has 20 students. Accidentally, all of the tests fall down and a few paper vanished. Therefore, he has only 17 tests out of 20, which means there is missing data, and this missing data is known as missing data is completely at random. Why? Because the probability of losing any test was the same and didn't relate it to the score of the test of question and anything else. Missing completely at random. When data are missing completely at random, that fact that the data are missing is dependent of the observed and unobserved data. We will discuss about missing data at random. In the same class, Ankit didn't give his exam because he was absent that day when a particular topic was being covered. Now, the teacher has 19 tests out of 20. This missing data is known as missing at random data. The probability of the test being missed is related to observed data because the attendance of Ankit was observed. For the probability for that day, Ankit didn't give his test, so we can say the probability only depends on observed data and is not related to unobserved data. So missing at random data, the probability only depend on observed data and is not related to unobserved data. If this is the case of, so the data missing at random, we can call the data missing at random. Missing at random means the probability for a data point to be missing is not related to the missing data, but it is related to sum of observed data. So what is the difference between missing at random and missing at not random and the missing at random? So the major difference missing completely random when data missed unobserved data, and here the observed data, the data missed but the data considered as a observed data. We will discuss about missing data not at random. In the same class, student X is not giving the test. The reason behind that, he is struggling to understand the material and the topic. Then we can say that this missing at random. It means missing not at random because the probability for here to related the unobserved data X was understanding the material when X present that particular day. Missing at random, when data are missing at random, the fact that the data are missing is the systematically related to the observed but not the unobserved data. So here what type of data we consider missing at completely at random? When the data is independent of the observed and unobserved both type of data. So missing completely at random, here only the unobserved data missing at random, here only the unobserved data missing not at random. Why it is important? As it turns out, keeping these two terms is important. Which mechanism you have in your data will affect which method you can use to deal with that missing data without beside your result. Now we will start examining data analysis. Why this chapter helpful for researcher because when researcher examine their data, and the behalf of that researcher decide which multivariate technique researcher should apply. Researcher should examine and explore the nature of the data. In the examining your data, what researcher do? The researcher explore the nature of the data and the relationship among variable before the application of any of the multivariate technique. This chapter help the researcher to do the following. First, select the appropriate graphical method to examine the characteristic of the data, relationship of interest. So what researcher do? Researcher select the appropriate graphical method to examine the characteristic of the data or relationship of interest. Use of multivariate technique place an increased burden on the researcher to understand, evaluate, and interpret the more complex result. It's required a thorough understanding of the basic characteristic of the underlying data and relationship. The first task in the data examination is to determine the character of the data. So for what is the first task? The first task is the examination is to determine the character of the data. A simple yet powerful approach is through the graphical display. So the simple powerful approach, what that show the graphical display, which can portray the univariate, biovariate, and multivariate. When we have one variable, so we can call univariate. More than one, biovariate, and more than two, so we can consider multivariate. Quality of the data in visual format for easy of display and analysis. The starting point for understanding the nature of single variable is to characterize the shape of its distribution, which is accomplished with a histogram. The most popular method for examining biovariate relationship, what is that? Is that scatter plot, a graph of data points based on two variables. We will discuss upcoming video what is the scatter plot method. Researcher also should examine multivariate profile. Three type of graph are used. So in multivariate profile, researcher use three type of graph. The first graph type is a direct portrayal of the data value, either by graphs that display the data as circle, or multivariate profile that provide a bar-like profile for each observation. A second type of multivariate display involves a transformation of the original data in a mathematical relationship, which can be portrayed graphically. The most common technique of this type is the Fourier transformation. The third graphical approach is iconic representativeness. These are the three type of the graphs which researcher used. Assess the type and potential impact of missing data. Although some missing data can be ignored. So when we already discussed missing completely at random, missing random, and missing not at random. So these type of the data, missing data, and sometimes missing data can be ignored. In the case of missing completely at random, we cannot ignore our data because the probability of the missing all of the data will be same. Missing data is still one of the most troublesome issue in the most research setting. At its best, it is a nuisance that must be remedied to all as much of the sample to be analyzed as possible in more problematic situation. However, it can serious bias in the result if not correctly identified and accommodated in the analysis. the 4-step process for identifying missing data and applying remedy is as follows. So these are the remedies: determine the type of missing data and whether or not it can be ignored. So first, researcher determine the type of data, whether it can be ignored or not, and then determine the extent of missing data and decide whether respondent or variable should be deleted. Diagnose the randomness of the missing data. Select the imputation method for estimating missing data. Let's we talk about the understand the different type of missing data process. A missing data process is the underlying cause for missing data, whether is be sometime involving the data collection process, poorly worded question, etc. of the individual. When missing data are not ignorable, the missing data process can be classified into of the two types. As I told before, missing completely at random data is not ignorable data, which denoted the effect of the missing data process and randomly distributed in the result and can be remedied without incurable bias. The second is MAR, which denoted that the underlying process result in a bias. For example, lower response by a certain type of consumer. And any remedy must be sure to not only fix the missing data but not incur bias in the process. Explain the advantage and disadvantage of the approaches available for dealing with missing data. The remedy for missing data can be follow one of two approaches using only valid. So the remedy of the missing data can be follow only one of two approaches, using only valid data or calculating replacement data for the missing data. Even though sign only valid data seems a reasonable approach, that researcher must remember that doing the full effect of any basis due to non-random data process missing at random. Therefore, such approaches can be used only when random missing completely at random data process are present. So when such approach uses when the missing completely data represent, and then only if the sample is not too depleted for the analysis in question. Remember, missing data exclude a case from use in the analysis. The calculation of replacement value attempts to impute a value for each missing value based on criteria ranging from the sample overall mean score for the variable to specify characteristic of the case used in predictive relationship. Again, the researcher must first consider whether the effects are missing completely at random or missing at random, and then select a remedy balancing the specificity of the remedy versus the extent of the missing data and its effect on generalizability. Identifying univariate, biovariate and multivariate and outlier. Outlier are observation with a unique combination of characteristics. Univariate we already discussed, one variate variable, bio more than one, multi more than two, and outlier are observation which a unique combination of characteristics indicating they are distinctly different from the other observation. These differences can be a single variable, univariate outlier, a relationship between two variable, biovariable, or the across entire set, it means multivariable. Outlier applied all of them. Although the case for outlier are varied, the primary issue to be resolved is this representativeness, and whether the observation or variable should be deleted or included in the sample to be analyzed. Test your data for the assumption underlying most multivariate technique. So researcher test the data, the assumption underlying most multivariate technique, because our analysis involves the use of sample and not the population. We must be concerned with meeting the assumption of the statistical interface process. That is the foundation of all multivariate statistical technique. The most important assumption include normality, linearity, and absence of correlated error. A wide range of tests from graphical portrayal to empirical measurement is available to determine whether assumptions are met. Researchers are faced with what may seem to be an impossible task: satisfy all of these statistical assumptions of risk, a basic and flawed analysis. These statistical assumptions are important, but judgment must be used in how to interpret the test for each assumption and when to apply remedies. Even analysis with small sample size can withstand small but significant departure from normality. What is more important for the researcher is to understand the implication of each assumption. So what is the most important for researcher? To understand the implication of each assumption with regard to the technique of interest, striking a balance between the need to satisfy the assumption versus the robustness of the techniques and research context. Determine the best method of the data transformation. Give a specified problem. When the statistical assumptions are not met, it is not necessarily a fatal problem that prevent further analysis. Instead, the researcher may be able to apply any number of transformation to the data in questions that will solve the problem and enable the assumption to be met. Data transformation provide a means of modifying variable for two reasons. So what are the two reasons? The first reason is to correct violations of the statistical assumption underlying the multivariate technique, and the second one to improve the relationship, means correlation between variable. Most of the transformation involve modifying one or more variable. For example, compute the square root and then using the transformed value in the analysis. It should be noted that the underlying data are still intact, just their distributional character is changed so as to meet the necessary statistical assumption. Understand how to incorporate non-metric variable as metric variable. An important consideration is choosing and applying the correct multivariate technique, because before applying the multivariate technique, if researcher will apply the not correct multivariate technique, so there is no valid research. So in that case, multivariate technique is the measurement properties of the dependent and independent variable. Some of the techniques such as discriminate analysis, this is the one of technique about multivariate analysis. In multivariate analysis there is more than 20 technique, and one of them discriminate analysis or multivariate analysis of variance. Specifically required non-metric data. So in discriminate analysis required non-metric data as dependent or independent variable. Many instances the multivariate method required that metric variable be used, yet non-metric variable are often of considerable interest to the researcher. A particular analysis, a method is available to non-metric variable with a set of dichotomous. Maybe I have to check its pronunciation. What is that? Wait a minute. Yeah. I'll check its pronunciation.
Dichotomous.
Dichotomous. Dichotomous variable that has been converted to a metric distribution and represent one category of a non-metric independent variable. Considerably time and efforts can be expended in these activity. So when the researcher will do these activities, so it require time and effort, but researcher wisely invest the necessary resources to thoroughly examining the data to ensure that the multivariate method are applied in a appropriate situation, because it is important and to assist in a more throughout and insightful interpretation of the data result. So we already discussed about examining data analysis. I hope your all point cleared about data analysis. Thank you.